Hello everyone, this is our second class of inverse trigonometric function. In our first class we have discussed that how can we find inverse of sine and cosine. Now here we are starting with tan. First of all, I have drawn this graph for y equal to tan x. We have drawn this graph for tan x. In our previous class we have already discussed what is the range and domain of tan, cot, sec, cosec, everything. So for tan, if we check our graph passes through origin, and that way we have taken this graph for minus 2 pi to plus 2 pi. Now when you write inverse of it, this graph became vertical. Here horizontal graph is drawn, it became vertical. So vertical graph I have drawn here. Now you already know how we have discussed in sine and cosine, same way. Sine domain became -1 to 1 and range became minus pi by 2 to plus pi by 2. Similar way in cos also. So for tan, your domain became r and range became minus pi by 2 to plus pi by 2. Why we cannot take pi by 2 and minus pi by 2 and plus pi by 2? See, at pi by 2, what is your value? Sin pi by 2 will be 1 and cos pi by 2 became 0. So 0 by 1 is 0. So we haven't taken open interval, not close. Same way for cot inverse also, you can draw the graph like this and then vertical graph will be for cot inverse, but its domain is r and range is 0 comma pi. Cot means same as cos. Similarly for cosec and sec, r minus 1 comma 1, but remember the interval is opened interval and the range will be, cosec's range is same as our sine, but 0 is subtracted because sine 0 is 0. So it's became infinitive. And for sec pi, cos pi by 2 is 0. So 0 comma pi, from that pi by 2 is subtracted. So this way we can make a inverse table. But remember, see, all the graph is already mentioned on your textbook. You can open your textbook, page number 37. On 37 page, graph of cosec and cosec inverse is mentioned. Similarly, on the back side of it, sec and sec inverse graph is drawn, and afterwards tan inverse, cot inverse graph also drawn. But the main important thing, that is this inverse trigonometric table. See, first we write both the tables. I wrote this graph because I think this graph is more clear to you. I have drawn 3 graphs. Similar way you can make another one. See how I have made this table. Similar way, let's write for sine, cos, then sec, cosec, tan and cot. We already know domain and range. Okay, what is the domain for sine? We are considering for sine, when we are writing for sine, you can see in your textbook also on the first page that sine functions, for sine function is given, domain is r and range is -1 comma 1. For cos also domain is r and range is that. Now for sec, r minus, what you have to subtract when cos became 0 and belongs to z. 2. R minus we have taken, not directly r, and the range will be r here. Similar way, sec became 0 at n pi and belongs to z, to r. Same way tan. For tan, remember tan and cot, for both one you have to take the same thing for sec, cot and for cosec this way. But the range became here r minus, for sec and cosec r minus -1 comma 1, and here it is r only. So all these things we have already, this table we have already discussed in our previous class. Just now we have discussed this table. So you just go through both the table proper way, so we can easily solve the questions. See, just we revise all the graphs once from your textbook. So you can open your textbook, check your first page. On the first page, this table is mentioned on page number 33, which one I have written here. Now turn your page. back side on 35 page, graph of sine function is mentioned, for which we have already discussed how to draw sine functions graph, how to draw sine inverse functions graph. Back side on 36 page, graph of cos function and cos inverse is mentioned. On 37 page, graph of cosec and cosec inverse is drawn. Remember, for all the graphs, meaning is same, method is same, horizontal graph for original function and inverse vertical. Because what is the theme of it? That range became domain and domain became range. On page number 38, another graph, sec and sec inverse. Similar way on 39 page, graph of tan and tan inverse mentioned, and last on 40 page, graph of cot and cot inverse is mentioned. And at the end of a page or explanation on 40 page, table mentioned, which one I have written here. So you just take a screenshot of it, otherwise you write in your notebook that how to make this table. After getting it, it's very easy to understand sum of trigonometric, inverse trigonometric functions. So before I start sums, just you revise one more time table and then we can start our exercise. See, few notes points are given. Remember, in first point, if I write sine inverse x, see, sine function is this way, we can write sine inverse. Sine inverse is not equal to 1 upon sine. Remember, if I have written full inverse, then you can say 1 upon sine x, but if I have written like this sine inverse x, it doesn't mean that it is 1 upon sine. This is the first point you have to remember. What is the second point? Whenever no branch of an inverse trigonometric function is mentioned, we means the principal value branch of the function. Wherever, suppose we are taking sine on minus pi by 2 to pi by 2. If it is not mentioned, then you have to consider this as a principal values. Third point is given, the value of an inverse trigonometric function which lies in a range of a principal branch is called the principal value of an inverse trigonometric function. So this is the end of explanation part. Now I explain you few questions, so it will be more clear to you how can we write inverse of it. Okay, our first question is sine inverse 1 by root 2 we have to find. So now the question arises, what is the value 1 by root 2? So for this we have to revise our knowledge that we have already discussed these things. 0 degree, then pi by 6, then pi by 3, then pi by 2, then pi, then 3 pi by 2, 2 pi, all these values you already discussed. Now I explain you only for sine function. First, sine 0 is 0, sine half, sine pi by 6 is half, sine root 3 by 2, sine pi by 2 is 1, sine this minus 1, and this is 0. So all these trigonometric values, how to make a table of it, you already learned in your 10 classes. So here pi by 4 I forgot. So it is 1 by root 2. Now remember, here what is given? 1 upon root 2. And for which trigonometric value sine is 1 by root 2? For pi by 4. So how can we write this function? Sine inverse, we can write sine pi by 4. Okay, up till this it's easy, that because we know 1 by root 2 is the value of pi by 4. And we can easily say sine inverse cancel and you can write direct pi by 4. But remember, whenever you write, you have to remember your answer should lies in minus pi by 2 to pi by 2 only, because for sine inverse, this is only your boundary. Your answer should lies between minus pi by 2 to pi by 2. If your answer is not lies in minus pi by 2 to pi by 2, you have to make in a given restricted domain. Then only you can find inverse of it. Okay, here it's very easy because pi by 4 lies between minus pi by 2 to plus pi by 2. Another question is given, cot inverse 1 by root 3. Okay, for which trigonometric value cot is 1 by root 3, that we know. But if a minus sign is mentioned, cot inverse minus 1 by root 3. So let's assume first this as a y. Now we can take cot y equal to minus 1 by root 3. Now we know 1 by root 3 value, we know it, but minus 1 by root 3. Okay, let's make a table of it again. Here both the positive value, negative positive, negative negative, positive negative. Now cot means what? Cos upon sine. Here cot positive, here also cot positive, cot negative in second and fourth quadrant. Now remember, minus 1 by root 3. 1 by root 3 is the value for what? Pi by 3. So it must be clear in your mind for which trigonometric value. What is the term? Pi by 3. But it is in a second quadrant. Why I have taken second? Because our domain lies between 0 to pi, means we can consider only first two quadrants. So if I take here, then according to trigonometric term, you can write pi minus theta in a second quadrant. So pi minus pi by 3 will be 2 pi by 3. So what is your answer here? 2 pi by 3. So this way you can solve all the questions of it, but for your understanding and for your convenience, we make a one table and chart for quadrant also and for values also. So it's easy for you to understand. Our first table, this one, theta, pi by 2 minus theta, pi by 2 plus theta, and last 3 pi by 2 minus, here pi by 2 minus theta, pi by 2 plus 3 pi by 2 minus and 3 pi by 2 plus. Okay, values both positive. First I have written for sine, second cos. First cos is negative, sine is positive, both negative, positive, negative. Okay, if you remember, we already discussed one sentence, all silver tea cup, shortcut, all in first quadrant, all positive, silver sine positive, tea tan positive, cup cos positive. So remember this shortcut ASTC, see, all silver tea cup. So easily you can remember this table. Okay, another table, same way, here theta, pi minus theta, pi plus theta, and last 2 pi minus theta. Again same, all silver teacup, positive negative, concept is same for both the tables. Now let's make a values term. First is 0 degree. After 0, what is the next value? 30 degree. Then 45 degree. Then 60 degree. After 60, 90 degree. After 90, we can say 180 degree and then 270 degree. 0 degree only your 360 degree also. Let's write first for sine. Sine 0, then 1 by 2, 1 by root 2, root 3 by 2, 1, then 0 and minus 1. Similarly for cosine function, cos 0 is 1, cos 30 degree is root 3 by 2, 145 degree is same. You can write this as a degree or as a values, radian measure and tangent measure you already learned in your previous classes. So I am not going in deep of it, I have written direct values. Now half, this is 0, minus 1, and at 3 pi by 2 again 0. Okay, let's make a for 10. For 10, sine upon cos, 0 upon 1, 0. This one, 1 by root 3. Division of it, 1. Division of it, root 3. 1 upon 0, infinitive means not defined. 0 upon minus 1, 0, and again not defined. Not defined, I have written dash. For cot function, now we have to write cos upon sine. So not defined. Now cos upon sine, numerator is this, denominator is this. So root 3, obvious, 1 by root 2 upon 1 by root 2 is 1. Now half upon 1 by root 3. So this is 1 by root 3. Cot, you can write cot means reciprocal of tan also, meaning is same. Okay, cot means cos upon sine, minus 1 upon 0, infinitive, and last, what is it? 0 upon minus 1 is 0. Now same way let's write for sec, and last for cosec. Sec means reciprocal of cos. So 1 as it is, reciprocal of cos, reciprocal of cos, reciprocal of cos, not defined, reciprocal of cos and not defined. Same way reciprocal of sine, not defined, 1 upon 0. This is 2, this is root 2, 2 by root 3. Now sine, 1 upon 1 is 1, 0 means infinitive and this is minus 1. So that way you have to remember all these things, then only you can solve inverse trigonometric functions question. So just take a screenshot of it, so it will be more clear to you how to find the quadrant. Now after getting all these values, remember this is your first quadrant, second, third and fourth. In first quadrant all positive, here sine positive, here tan positive and in last cos positive, all silver teacup. You have to remember with this. So I think if this thing is clear to you, you can easily solve the questions of trigonometric functions. Okay, now let's remember, here we have shortcuts also. We have already discussed in our 11 classes that how to make a table. Whenever you solve the trigonometric questions, first you make this table and you draw these charts. So it will be easier to understand for sine. If you make a simple single mistake in a sine, then only you will get 0 mark, and these questions are too much important as far as MCQ concerned. So we discuss few 2-3 more questions based on it, and then we can start our exercise. Okay, I give you one question. Suppose you have given tan 1 by root 3. Okay, tan 1 by root 3 means what is the trigonometric value for tan root? It is 1 by root 3 for pi by 6. So I can write tan inverse tan pi by 6. Tan inverse cancel. I get direct answer pi by 6. But I just make a little bit change in it and I make it minus 1 by root 3. Now remember, tan is negative in which quadrant? Second quadrant. So when I write this, I can write tan inverse tan pi minus pi by 6. Why I have written pi minus pi by 6? Because in second quadrant tan is negative. So if tan is negative, your term will be pi minus theta. So tan inverse cancel and pi minus pi by 6 will be 5 pi by 6. Now remember, for tan, pi by 6 also in a given range, 5 pi by 6 also in a given range. So if it is not in a given range, then we have to make a in a range, then only we can solve the trigonometric question. Okay, one more example we will take, sine inverse half, and another question sine inverse minus half. Okay, for which trigonometric value sine is half? You already know pi by 6. So sine inverse we can write sine pi by 6. Sine inverse we can cancel it, so pi by 6. Similarly, if I write sine inverse minus, sine is negative in again second quadrant. So how can I write sine pi minus pi by 6 if it is pi minus pi by 6? So sine inverse sine 5 pi by 6, and what is your answer? 5 pi by 6. Now 5 pi by 6. 5 pi by 6 means what? 5 into 30. So 150 degree, and 150 degree, is it lies between minus 90 to plus 90? No. So we cannot take this value. So what can we do? If we cannot take this value, then how can you write? Sine is negative again in this quadrant. So what to do? Sine 2 pi minus pi by 6. If I write, okay, 6 2s are 12 and minus 1. So this way, now you check, it is 11 pi by 6. So if I write 11 pi by 6, 11 into 30, so it is 330. We cannot take this also. So what to do? Remember, here sine is negative in second quadrant, but our range for sine is minus pi by 2 to plus pi by 2 only, this way. So whenever this type of question arise, you have to convert into with minus sign. So we cannot write 5 pi by 6 also. But in fourth quadrant, if we go anti-clockwise, we can write minus theta also. So here what to do? on place of writing this, we can write sine inverse, sine minus pi by 6. Sine inverse cancel, so answer is minus pi by 6. But on place of sine, if here cos is given, then what to do? Cos pi by 6 you can write pi by 3, and your answer is cos pi by 3. That is there. Okay. Similar way you can continue with all the terms. I think for today this much is enough. We discuss the same thing and all the examples in our next class also. Thank you.